In this example, a cannon is firing off a cliff. The height of the cliff is 100.0 meters. The cannon fires with an initial speed of 150.0 meters per second, and in this case, it's aimed at an angle of 0 degrees. And the question is, what distance from the edge of the cliff will the cannonball end up reaching by the time it hits the bottom? In order to solve this problem, we first have to figure out everything that we know. Now this is a two-dimensional problem, and remember what I've been harping on. To solve two-dimensional problems, you break them up into two one-dimensional problems. So let's think about what we know in each dimension. Well, we know the initial velocity. It's 150.0 meters per second at an angle of 0 degrees. We can split that up into its x and y components. The y component of the initial velocity is simply the magnitude, 150.0 meters per second, times the sine of the angle, 0. Well, that works out to 0. So the y component of the initial velocity is 0. The x component of the initial velocity is the magnitude once again, times the cosine of the angle. That works out to 150.0 meters per second. So the initial velocity in the x dimension is 150.0 meters per second. We also know about the acceleration in both dimensions. In the y dimension, the acceleration is negative 9.8 meters per second squared, because the projectile is falling under the influence of gravity. In the x dimension, the acceleration is 0, because nothing's pushing or pulling on the projectile in that dimension. So that's basically everything we know. How are we going to use this to solve the problem? Well, in these two-dimensional problems, remember, we're splitting them up into two one-dimensional problems. And generally, we need to find something in one dimension to solve for something in the other dimension. Well, we're trying to solve for the distance, and the distance is in the x dimension. So most likely, we have to figure out something in the y dimension that we can use in the x dimension to get our answer. So let's start in the y dimension. In this dimension, we know the initial velocity, we know the acceleration, and we know the displacement because we're given the height of the cliff. Now, if you think about it, there's a relationship that relates initial velocity, acceleration, distance, and time. So we can figure out how long it took the projectile to travel by solving equation 2.19 in this dimension. The equation tells us that delta x equals v naught t plus 1/2 at squared. Delta x is displacement. What's the displacement in the y dimension? Well, it's negative 100.0 meters. How do I know it's negative? Well, I defined traveling down as negative because I gave the acceleration due to gravity a negative value. Since the projectile falls down 100.0 meters, then its displacement is negative 100.0 meters. The initial velocity, as we've already determined, is 0. We don't know the time, but we do know the acceleration, negative 9.8 meters per second squared. And once again, we don't know the time. Well, now look, the only thing we don't know in this equation is time, so we can solve for it. The first term on the right-hand side of the equation drops out because 0 times t is just 0. So I can solve for t squared by multiplying by 2 and dividing by negative 9.8 meters per second squared. When I do that, I find that t squared is 2 times 100.0 meters divided by 9.8 meters per second squared. The meters cancel, and when I take the square root of both sides, I find that t is 4.5 seconds. Well, that's something else that we now know. So we can take that 4.5 seconds and stuff it into the we know column. So in addition to everything else, we know that the time that the cannonball travels is 4.5 seconds. Well, it turns out that that's the crucial piece of information we need to know to calculate the distance traveled in the x dimension. If we look in the x dimension, we now know the initial velocity, we know the acceleration at 0, and we also know the time it travels. From that, we can calculate distance if once again we use equation 2.19. Delta x equals v naught t plus 1/2 at squared. We don't know delta x, but we do know the initial velocity in the x dimension. It's 150.0 meters per second. Time is 4.5 seconds. In this dimension, the acceleration is 0, and the time is 4.5 seconds. Look what happens. The second term on the right-hand side of the equation drops out because 0 times anything is 0. So the displacement is simply 6.8 times 10 to the 2 meters. So the cannonball lies 6.8 times 10 to the 2 meters from the edge of the cliff when it hits the ground.